Hi everyone, today is going to be a posters here video. I didn't actually want to do a posters here video. I wanted to do something a bit more interesting, but I just haven't got around to preparing it and stuff. Sometimes these videos take quite a while to prepare and to research and stuff. Anyway, so posters here video, and hopefully next week I can do something more fun. So posters here, let's see what I've got. The first thing is something pretty boring really. What's this? These are little clips. So the idea is you push there and put it around a wire or something, and you can leave it connected like a little testing clip thing. And obviously you put some wire on there. Usually these pop off. Yeah, there you go. So that pops off there like that, and then you put the wire through this hole here. Just take that off again. Put the wire through there. You solder it onto this little copper piece, and then put it back together, and that's it. Cool little testing things. Now I need to show you how this works. Let me just see. In fact, no, it's common sense anyway. So I have loads of those. Now I've probably got those very cheap. I've been meaning to make some of these for quite a while actually. Well, not make them, but you know, make the wires so that I can test things out. So I've got 2 packs of those. I don't know if they're from China. I suppose they probably are. What's next? This is quite a mismatch of different bits and pieces actually. Next thing is this, and this is, I know what this is. This is a network cable socket. It might be better known as RJ45, I think. And these are PCB things, so basically you drill a hole in the PCB, push those in, and actually they go like that. And you put your cable into it, and of course it allows you to have 8 pins or 8 wires, so you can transfer power and signals across it. Incidentally, if I remember rightly, the 802.11b, is it? I think maybe it is. I could be wrong. But the actual standard that we use for our PCs and stuff, it doesn't actually use all 8 pins. It uses 4. And from memory, they are data, ground, and then 2 twisted data pins. From memory, anyway. So I've got a few of those, and I'll probably use those for solar. For, you know, sending and receiving data throughout the system. I haven't done anything with solar for such a while. I want to get into that again and sort some things out. And what's next? I've got, what's this? These ones where the tab is so thin that you can't actually open it. Right, what's this? It's, let's see. It says 74HC595D. What on earth is that? 74HC595D. Well, it appears to be a 16-pin IC. I don't know what that is, but we'll find out. So that's that. What's next? Ah, right, I remember buying this. Now again, remember a few weeks ago I did a video on it was some sort of sensor, I can't remember now, but it was a very simple one, one that you usually do at the very start when you're learning Arduino. I can't remember exactly what it was, but it was it was a basic, I think it was a DHT22 or something. It's something very simple. Well, this is another one as well. This is another very simple Arduino project, which usually beginners do very early on. But again, I seem to have skipped this and gone mad with the more complicated stuff. Anyway, so this is a water sensor, and I don't know exactly how it works, but what I do know is that when droplets of water congregate, if you like, over these pads here, it has some effect over here, and it changes the signal which is sent to the Arduino. I suppose it's quite cool that you have this little grip here, so when you put it into the soil like that, you can just pull it out if you need to. So yeah, it's a water sensor. The idea is, or from what I remember, the idea is that you put it into the soil. I suppose you could actually leave it up like that as well for rain, but you'd have to seal that off. You know, all these chips there, otherwise, of course, they get corroded. And in fact, even if you had that in the garden and you had it upright like that, it would probably still get corroded. So I'm not exactly sure how this is designed to work. You'd probably have to put some sort of silicone gel over it or something. I don't know. But anyway, it's a water sensor. So I'll put that back over there, and I've got one more product. Now I've had this one for a long time. And I've been meaning to show you for ages, but I never got around to it. And this is quite an interesting item. These are little, well, I don't actually know what, like slates or something. Little fragments of solar cell. So you can see here I've got loads of different, loads of different fragments here, and each one of these will generate a certain voltage, and even more voltage under sunlight, well, light basically. And you can see them there, they're really cool. So you get like a bus wire and another type of wire that connects over these here. When you heat the special wire, it's like a ribbon, it's already pre-tinned, so they adhere really well. Yeah, so bus wire, and there's another type of wire which is a bit thinner, I can't remember what it's called. Yeah, these are pretty cool. Have you seen how thin they are? Look. Super thin. They're also extremely brittle, as you can see here. I mean, look at this. See how brittle it is? You just smash in your hands like that. Just chuck that one away. So I've got quite a lot of these. Let's just have a better look at them, I suppose. And I think these are polycrystalline. There's actually different types you can get. You can get monocrystalline and polycrystalline. And I think these are polycrystalline. I'm just looking through these and seeing how many of these are broken. Like I said, they're extremely fragile. I don't really know how they've got these things. I assume maybe these are rejects or something, and when they've got these rejects, they've cut out the pieces that they can salvage and slice them up into little pieces like this, ready to be sold, I imagine. But with these things, you can make your own little solar panels by using the bus wire and the other wire. So there you go, you can see how kind of thick they are. There's probably about 30 in there or something like that. And these ones are broken. I suppose you might as well have a closer look. They're wafer thin. Anyway, there you go. So that's everything for today. That's everything in this video. So now I guess it's time to see where I got the stuff from. So I'll show you that now. Wholesale 10 times multimeter lead wire test probe hook clip set grabbers connector. You get 10 of those from this seller here, WYG-WXL for 99p. There's not really much point in going into the description because you can see there they're just test clips. So we'll move on. Water level sensor, water droplet sensor of depth for Arduino Red X2G9GL. And there's a picture of it there. So that's the water sensor, of course, from Fly.Planet for 99p. I wonder what it says. Right, it says it's an analog sensor. Okay, so it's not digital. Operating current less than 20 milliamps. Operating temperature 10 to 30. Area of detection. So that's the area which detects water. Material is chip. Operating voltage 3 to 5, which is about standard. Moisture, blah blah blah. Right, okay, so that's cool. 99p from Fly.Planet. The next thing is B8DA connectors test equipment RJ45 bonder ABS female 8P8C business industrial from X-web-top, and that's 99p for 5. And you can see there in the picture that there's one in a what looks like a laptop. There's some more pictures here as well. And basically you just plug an RJ45 network cable into it, and you can transfer data or power. And it's got written in here rated current 2 amps. 2 amps, that seems like quite a lot for such thin wires, but anyway. Contact resistance, rated voltage, frequency range, blah blah blah. These are mainly theoretical. I don't think you'd ever really pump 250 volts through an RJ45 cable, but whatever. And neither would you put 2 amps, but whatever. So they're network cable sockets, and what's next? Did I say how much they were? I think I did, didn't I? 99p from there for 5. Next thing, right, now I couldn't find the actual auction, but I could find this. So, by the way, the reason is because I bought them over a year ago probably, and I just kept forgetting to do a post this here video. Anyway, 10 pieces polycrystalline mini solar panel DIY cell sun power battery charger module. You get 10 of these little things, which to be honest these look better than the ones I've got. Although probably just cuttings, the same as mine. They certainly look, actually they do look very similar. £3.15 for 10, which is a little bit expensive for what it is, I suppose. It says yin.f from Hong Kong, and what does it say? Just some little details like the amount of wattage, the amount of voltage, current, efficiency. So it would be quite cool if I was to put these in the sun and test this. I suppose that would be a good video for springtime or summer. I might do that. I'll have to solder the bus wire to it though, and whatever the other type of wire is called. What's next? So here we've got 12 pieces IC74HC595D from KN35, and it was 99p for 12, which is very good. It's about 8p each or something like that, which is about, is it about, well, in fact I don't know what it is in dollars, but so it's a shift register. Right, so shift registers. Now I've never used a shift register before, but let's assume we have a microcontroller and we want some more digital outputs and we've not got space. You could add the shift register to help you out. So let's just draw a shift register. So 3, 4, 5, 6, 7 and 8, and we don't need that. So we've got a shift register here, and we want these extra outputs. So if you remember rightly, microcontrollers have a serial port and you have a TX and an RX. Now certain shift registers can have an RX, and of course microcontrollers have a TX. So you go from TX to RX, and you can send this shift register a byte. So now what on earth has this got to do with having more outputs? Well, what happens is that if you were to say send 255 as a serial as serial data to this shift register, what would happen is that the value of this shift register or array would represent the 255 which you've sent it. So if you were to clear it and then send it something else, then the value of this would change. So of course the representation of 255 in this would be all of them. How many 128s? 1. You know, how many 64s? 1. How many 32s? 1. How many 16s? 1. How many 8s? 1. How many 4s? 1. How many 2s? 1. How many 1s? 1. So if you add it all together, it will be 255. Like that. And if you were to send it the byte 128 or something, or anything really, then the shift register would change its value according to that. So now what's the point of this? Well, the point is that these represent here different outputs. So you've used serial here, but now you've got different outputs. So if you send 255, then what you are saying is that all 8 outputs are high, logic high. Or if you change the value in such a way that this one was 0, you'd get high, 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 low, high, high. And basically if you were to do something like put LEDs across here, or something else. If you were to feed some sort of circuit down here for each of the 8 things, you'd be able to control each of the 8 smaller circuits independently of each other, and that's my understanding of a shift register. So pretty cool, isn't it? I've never used one, but maybe I will in the future. I suppose it'd be handy for certain things. Anyway, I hope that's helped, and yeah, I hope you enjoyed the video, and as always, thanks for watching. Bye.